Okay, today I'm making the classic redox demonstration blue bottle and a couple of variations on it as well. So I'm just going to start with weighing out some glucose. Now it's definitely possible to use other reducing agents, and I've heard of people using things like vitamin C and dextrose, but I'm not too sure about the other reducing sugars. We've always got glucose on hand, so I'm just going to be using glucose today. Now this demonstration is a real classic. We use it for open evenings, A-level chemistry taster sessions, and obviously when we're teaching redox at GCSE and A level, and even when we're doing Year 7 Introduction to Chemistry. It's really accessible for teachers, especially student teachers. This is a perfect kind of first demonstration for a student teacher to start with. So I've got my weighing boat here, and I'm just going to tear the balance, and I'm going to go for 10 grams of glucose. Now I'll skip past the boring part of me just weighing this all out. This balance is really annoying. It's really unreactive and really slow to respond. And actually you don't need to be super accurate with these measurements anyway. We're just looking for a basic glucose solution. So we'll adjust the pH in a little while. So I'm just going to transfer this to a little pot. I always store a few of these on the go at one time. I've probably got about 5 on the go at one time, just in case I ever need it in a pinch. It makes prepping really easy. So I'm just going to pop this in the pot, and that will stay on the shelf for most of the term until we need to use it. Next up is our alkali component. So we're going to use potassium hydroxide, but I've definitely seen people use sodium hydroxide before as well, and calcium hydroxide. I feel like the potassium hydroxide probably stores a little better. I don't think it reacts with the glass as easily, as readily as sodium hydroxide does. So I've got some pellet here, which is kind of annoying to work with as well because it's impossible to get it bang on the target weight you're looking for. So I might overweigh this a touch, but again, like, I don't think the weights, accuracy of weights, are necessarily that important. It's got to be alkaline. The environment has to be alkaline for the glucose to reduce properly. Target here is 8 grams. I've overshot it here by 0.05, but there's no way I'm pestle and mortaring this potassium hydroxide, so we'll just leave it at that. I'm just going to add this straight to the Duran bottle. Just need my water, grab my squeezy bottle, and then I'm just going to transfer this into this Duran. I probably should have added some water to the Duran first. When you add potassium hydroxide to water, it gets hot, and so really what you want is like a nice volume of water to add it to. And the target volume here is 300 ml. So we're doing 8 grams in 300 ml of distilled water. So just checking for heat as we go, and I'm just going up to the 300 mark on the Duran. So again, not super accurate. Really just looking for round about 300 ml, round about 8 grams. And then we're just going to make sure that's really well dissolved and make sure that solution's gone nice, clear and colorless. Now remember, that solution is definitely higher than room temp at the moment, so we are going to have to leave that on the side for it to come down to room temp. We don't want to use it hot. So this is storage. I'll batch make 300 ml of potassium hydroxide, 8 grams, and 10 grams of glucose, and that will keep nicely for months. So now we're going to set up the demonstration. Some teachers like to do this in the class, but most of the time I'll do this in the lab and then take it into the class once it's been prepared. So I'm just going to tip my 10 grams of glucose into the flask using a funnel. This funnel's got the end cut off, so it makes it really easy to transfer powders as long as they're not caked. If they are caked, you can just use a stirring rod, thin stirring rod, and push it down. I'm just going to add the KOH. I could be using the funnel for this. If it was a teacher, I would probably recommend to just leave the funnel and add it via the funnel. For recording this video, I've had to make a few of these, and so I'm going to use the funnel a couple of times. Again, doesn't have to be super accurate, but I'll try and get everything in there. And then once that's in, I'm just going to give it a nice shake about and try and get that glucose to dissolve into the potassium hydroxide solution. Now I'm going to add our methylene blue. Now the methylene blue that we use as kind of shelf methylene blue is been diluted down for ideal use for cheek cell staining, and so actually it's quite weak. So I'm going to add maybe 10 or 12 drops, quite a lot of methylene blue compared to what you would normally add if you were doing a 1%. I think, don't quote me on this, but our methylene blue is at about 0.2%. I don't know, the biology technician makes it up. So I'm just stirring everything up and just making sure that everything's nice and dissolved and homogeneous. And now, once that's all good to go, I'm just going to let that sit on the side. So sometimes when I'm doing this demonstration, I might make it in front of the kids, and then I'll leave it on the side. And what I'll do is I'll just start clearing up. So that's what I'm going to do now. I'm just going to start clearing up while that solution rests. The idea here is I'm trying to distract the student, so I might say, okay, I'm just going to leave this on the side now while I clear up, and we'll come back to that in a minute. So I'll just pop all of my stuff away and kind of maybe start doing a little spiel about oxidation reduction. I want them to take their eyes off the solution just for a second or two, because while I'm doing this, you can already see in the corner there that it's gone colourless. So if we're doing other demonstrations, I might just do another demonstration, then come back to it. Point when we come back to it, they'll say, oh, it's gone colourless. And I like to gaslight them a little bit at this point and say, oh, what are you talking about? It was never blue. After a little while, we'll do the reveal. So just shaking it and trying to dissolve oxygen that's in the air in the top part of the volumetric flask into the solution will turn it blue. So just getting them to think a little laterally here, I might say something like, what is it in the flask? And eventually fish for the answer, liquid or chemical in the bottom of the flask. And then once they've got the answer for what's in the bottom of the flask, I might say, what else is in the flask? What's in the top of the flask? Fishing for air or gas or oxygen. So we add our methylene blue to the alkaline glucose. The glucose reduces the methylene blue. When methylene blue is reduced, it goes from blue to a colourless solution. So on standing, that is reacting, the glucose is reacting with the methylene blue, and it is reducing it and causing it to turn colourless. As we shake it, we start dissolving oxygen from the atmosphere into the solution. That oxygen then reacts with the methylene blue and it oxidizes it, turning it back into the blue form. And then if we were to leave that on standing again, the cycle will go back round. The oxygen will slowly start to come back out into the atmosphere, out of the solution, and it will turn colourless. If we're teaching oil rig, oxidation is loss, reduction is gain. We can see that hydrogen on top of the nitrogen in the center, kind of coming and going as it's being reduced and oxidized. So a quick variation using rezazurin. There are a bunch of other dyes that you can use as well for green bottle, but this one is called the disappearing Valentine. So I'm going to use a little bit of rezazurin, which is the indicator that we use for milk testing for bacterial content. So we actually have this in tablet form, and I just pestle and mortar it down. And I've added way too much here. You really don't need to add a lot, and it's quite a sensitive indicator in terms of this reaction. And you'll notice the difference between it and methylene blue later on. But yeah, I've definitely added way too much rezazurin into this solution. It starts off with this really nice deep purple color, and then that will slowly change as time goes on. Another thing with this fine powder is you get it up the sides there, so you can see it's got stuck up the sides of the volumetric flask, but no worries, I'll just grab a bung, a couple of shakes and get that off the neck. And then on standing, you'll get this beautiful pink colour forming, clear on further standing. So what I might do is give one bottle to one student and maybe another bottle to another, shake them both at the same time, and they both turn different colours. Really, really lovely deep pink colour there. But if I do give them to the students, I'm going to make sure they don't shake it by the neck and they support it really well, and they're not going to shake it too vigorously. The methylene blue tends to go a little bit slower than rezazurin, but I've grown to really like the delay between the two when you do them at the same time. Here you can see I've added way too much rezazurin. It's so sensitive, just a tiny shake, and that will go pink. With these solutions, you'll get around 20 cycles or maybe 45 minutes worth of cycles. Forgot to actually film a spent one, but you can see a spent one in the top right angle of this shot. It will turn from clear to yellow on standing and won't really react anymore. And disposal was just plenty of water down the foul drain. Okay, that's the blue bottle demonstration and disappearing Valentine. Hopefully, we'll be looking at doing the traffic light demonstration next. But these are just really simple reagents and really accessible chemistry. So let me know how you get on, and we'll see you next time.